All right, what do you say, guys? Let's get this going. We are going to get into triangles today. Now I'm going to introduce triangles and how it relates to being similar to each other. Two triangles being similar. Quick review. Back in Unit 4, I showed you two triangles being congruent. If two triangles were congruent to each other, we knew that corresponding angles were congruent, right? A little thing we like to call CPCTC. If the triangles were congruent, the corresponding angles were congruent. Let me go back to your notes. That is also true if two triangles are similar. If two triangles are similar, the corresponding angles are congruent. So here we go. A, B, C, Z, Y, X. I'm not going to ask anybody, but I don't know if anybody is familiar with the symbol for similar. The symbol for similar. Basically, take your congruent symbol and get rid of the equal sign. What you're left over is this symbol. There's your symbol for the similar. Oh, hey, it's just a little squiggly line. Yeah, that sounds real mathematical. It's the squiggly line. It's called a tilde, if anybody's wondering. If you want to impress your friends later, tilde. Not a squiggly sign, a tilde. So if those triangles are similar, I just mentioned corresponding angles are congruent. So I'm just going to mark a couple here for you. B is congruent to X. And then we already know the remaining two are congruent, but just to show you. Okay? So if two triangles are similar, corresponding angles are congruent. Here is the difference between similar and congruent. When two triangles are congruent, you guys know that the corresponding sides are also congruent. But in similar triangles, the corresponding sides are in the same ratio. Take a look. Corresponding sides are in the same ratio. They're not congruent, but they are in the same ratio. All right. If you guys right now match up any two sides in my triangles right now, it creates a ratio. If you match up another two pair of sides, it creates the same ratio as the first one. Okay? So once again, corresponding angles are congruent. Corresponding sides are proportional in two similar triangles. Any issues with those two facts? Okay. Just like we did in our proofs for congruent triangles, you are going to have to write statements that say two triangles are similar now. Rules still apply. The rules still apply. You still need to match up the sides and the angles correctly. Okay, when you write this statement, you still need to match up the sides and the angles correctly. All right, so if I name this triangle ABC, how would I have to name this second triangle then? ABC. How would you name the second triangle? I'm going to call on somebody here. Make sure the angles match up for me. Triangle ABC, similar to, let's start this off, 2, 3. Here we go. Luke, how would you name that second triangle if I called my first one ABC?
ZXY.
Hold on, though. If you go ZXY, you're telling me A and Z are congruent, and that's not what I marked. You got to make sure A matches up with its congruent angle in the second triangle and so on. So I don't want to start calling off by calling it Z.
Is it YXZ?
Okay, YXZ. Better. All right, everyone see that. You got to make sure your congruent angles match up. And last thing, make sure you're putting the similar sign in between. You guys have been just in the mode of putting congruent, haven't you? You've been so in the mode of putting congruent. Now I just got to retrain my brain to put similar there. And the last, this is a two new vocabulary terms here. Scale factor and similarity ratio. They both mean the same thing. Scale factor and similarity ratio. That is the ratio of two corresponding sides. The ratio of two corresponding sides. So you give me the length of one side over the length of its corresponding side. Let somebody help me out. What? Go ahead.
Do you see that the similarity ratio is the definition you just put down, or that
both are the same? Because I may ask for scale factor, the book tonight may ask for similarity ratio, but both are looking for the same fraction. Okay? Okay, help me out here. 8. Here we go. Ryan, can you give me two sides that match up? The lengths of two sides that match up.
2 and 6.
2 and 6. Fine. Ryan could have also gave me 3 and 9. He could have gave me 4 and 12. It doesn't matter which one he gives me because you guys see they're all in the same ratio. And remember, we talked on Friday, you could also write it like this with the colons, 2 to 6. Reducing if you want. I'm not going to require it. Reduce if you want.
Why is the ratio 2 over 6 instead of 6 over 2?
I'm just going left to right here. Most of the time they'll say, what's the similarity ratio for triangle ABC to triangle XYZ? All right, I'm just using the left and the right here and going that way. Okay? Hopefully, I believe on the homework they actually tell you what triangle to what triangle.
And do we need to simplify that into 1/3? Or?
That's your call. I'm not going to require it. That's up to you. All right. So we know what happens when two triangles are similar with their angles and sides. We know how to write it. And now we know this similarity ratio scale factor term. Now the good stuff, which is how do I prove triangles similar? You guys remember back in our day we had 5 ways? 5 ways to prove triangles congruent. I'm not interested in reviewing those right now, but we did have 5 ways to prove triangles congruent. Similar triangles, there's 3 ways we're going to focus on. 3 ways of proving the triangles similar. The main way, you'll see us use the most, especially when we start proofs tomorrow. Angle, angle. 2 triangles can be proved similar if you can prove me 2 pairs of angles are congruent. That's it. Nothing about the sides. If you can prove me 2 pairs of angles are congruent, those are similar to each other. Angle, angle. Look at example 1 I have here for you. Can we prove these 2 triangles similar? Well, I'm going to do kind of like a semi-proof here, not a full official one, but a little semi one. We already know that angle H is congruent to angle S, don't we? That's given to us, right? That's given to us because they're both 45. All right, let me turn it over to you guys. Can you guys tell me anything else on this diagram that must be congruent based on your vast geometry experience this year? Anything else congruent on that diagram? 10, here we go. Atticus, anything else congruent on that diagram? Am I calling on people that aren't even here? Yes, I am. All right, so let's go back. How about 4 now? Gideon, name another 2 pieces that are congruent here. If you're trying to talk, we cannot hear you because you're on mute. This is turning into the longest problem ever. Gideon, do we know another 2 pieces that are equal to each other?
Did you call me? I didn't.
I did, yes. What's another 2 pieces that are equal?
UOH and EOS.
Why? Why did you say those two?
Because they're vertical angles.
Okay, good. Vertical angles are congruent. All right, that's it. Guys, that's it. Angle, angle. We're out. Somebody give me a similar statement now. Now give me a good similarity statement. I proved two pairs of angles congruent. That's enough to say the triangles are similar. Give me a nice similarity statement now. 1, 9. Let's roll. Sean, give me a similarity statement. Triangle.
Triangle UOH is similar to triangle EOS.
EOS. All right, I'm good with that. Only thing you may want to take a look at, guys, did you put the similar sign or the congruent symbol? One job. One job. Erase it. You don't have to tell me. You can erase it. And by angle, angle. Those two triangles are similar by angle, angle. Probably the most used one that we'll have is angle, angle. There are two more. So any questions on angle, angle? All right, number 2. Oh, this looks a little familiar, huh? Side angle side similarity. Side angle side, but it is different. It is different than the side angle side for congruent triangles. Here's how. Yes, the angle still needs to be, take a look, the angle still needs to be in between the two sides. Yes, that is still true. But the sides do not have to be congruent. The sides need to be in the same ratio, though. The sides on the triangle still need to be in the same ratio. Here's what I'm talking about. The 10 here in the little triangle matches up with the 15 in the big one, and the 12 in the small one matches up with the 18. I need to check if those are the same ratios or not. If they are, then it's side angle side. All right, how do I check? How do I know if two ratios are equal to each other? Two different ways. You can reduce 10 over 15 reduces to 2/3. 12 over 18 reduces to 2/3 as well. Another way you could check, and this is the way I always like to check, cross multiply. If you do 10 times 18 and 15 times 12, you'll see that they're equal to each other. That's another way to check to see if two ratios are equal to each other. If when you cross multiply, what they equal are the same.
Is there a way you're supposed to know whether or not, I don't know if this is something you just figure out on your own, but is there a way of knowing that, oh, I need to put 10 over 15 as opposed to putting 10 over 18?
Small to small, big to big. Right? The smallest side should always correspond with the smallest side in the other triangle. Biggest side should always correspond with the biggest side in the other one. Okay?
All right.
And then that is what I'm leading into with my third method, which I'll get to in a minute. Everyone all right with side angle side? All right. Look at the two right triangles I have here. Why are these two similar? Same thing I did with the last example. Well, I already know A and D are equal because you guys remember right angles are congruent. So there's my angle. Now what I need to do is, if this is going to be side angle side, those sides should be in the same ratio. The sides should be in the same ratio. So 8 over 6 should be in the same ratio as 4 over 3. And I do want to just make sure I make this point. That's not the only ratio that's correct. You could have said 6 over 8 equals 3 over 4. That's fine too. All right, I just don't want you guys to thinking that's the only way to set it up, because it's not. All right, and if you do cross multiply, what do you notice? 24 equals 24. So that's good. Or if you reduced it, you would have seen 4/3 equals 4/3 for me. So they are similar. So write a statement for me now saying they're similar. Go ahead and write a statement saying they're similar now for me. 1, 2, here we go. Lucas, make sure those angles match up. Here we go, Lucas. Triangle, start it off.
Triangle ABC is congruent.
Oh, yeah, watch your mouth. Similar to?
triangle DEF.
Darn right. There we go. Now, just pay attention what I'm going to write for the reason now. Ready? By side, angle, side, but I can't leave it like that because that means you just proved two triangles congruent. So we do need to add on the tilde there, side, angle, side, similarity. Okay? If you just write the side, angle, side without it, that's the reason to prove triangles congruent, not similar. Any questions on side, angle, side similarity before I get to the last reason to prove triangles similar? You guys feeling all right? All right, the final reason also should look familiar to you. Side, side, side. Side, side, side. All right? But again, the sides aren't congruent now. I don't want the sides to be congruent. I want all three pairs to be in the same ratio. All three. All three. Hey, I got 2 out of 3. I'm good. No, you're not. It's got to be all three to use side, side, side. And let me go back to what Sophia just asked. How do I, and I'm not, this isn't in a Sophia voice. This is just my random student voice. How do I know what sides to match up, right? What sides do I match up? Smallest to smallest, biggest to biggest. That's what you can always rely on. Smallest to smallest, biggest to biggest. So in my example here, you'll see that 5/10 is in the same ratio as 8 is to 16, as 13 is to 26. That's what makes those two triangles similar by side, side, side. And you'll see, yes, 1/2, 1/2, 1/2. I would not recommend cross multiplying to see if the ratios are equal because you have to cross multiply every single scenario of 2, and that wouldn't work too well. All right. So we got angle, angle, side, 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 side. Any issues before I give you 2 random triangles and ask if they're similar or not? Any issues on those 3? Ask away. Oh, also, I should mention too, before I move on, let me go back to the side, side, side one. I wanted to make a point here. Can you guys, you have calculators, I don't think you need them. Can you guys find the perimeter of the smaller one real quick for me? What's the smaller of the perimeter of the smaller one there? 8 plus 5 plus 13, 26. And find the perimeter of the big one. 16, 26, 10. You should be getting 52. Notice anything about the ratio of their perimeters? Go ahead and chime in if you see it. 26 and 52. What's so special about the ratio of their perimeters as well?
Also 1/2.
Also 1/2, yes. If 2 triangles are similar, their perimeters will be in the same ratio as their sides. Okay, so just a little heads up on that. All right, the perimeters will also be in the same exact ratio as the sides. So 1/2. Good. All right, here we go. Example 1. I marked the diagram with 2 congruent angles. Are they similar or not? And it's got to be by one of our 3 methods. So first thing, can you mark anything else on the diagram? Anything else congruent here? 1, 5. Will, anything else congruent here, Will?
Angle AXB is congruent to cube XR.
Why?
Vertical angles are congruent.
You got it. Vertical angles are congruent. Stay with me, Will. Is that enough information to prove the triangle's similar?
Yes.
Yep. So you want to write a similarity statement? I'm putting you on the spot here, Will, because I know you can handle it. You want to write a similarity statement for me?
Triangle RXQ is similar to AXB
Got it. By what method, Will? Finish this off strong.
by angle.
Done. Nice job, Will. Good way to put it all together. Also, some of you guys have some self-respect. Are you still writing the congruent symbol? Have some self-respect, please. Are you still writing the congruent symbol? All right. Good job. Well, nice. All right, let's go to 2, everybody. Whew, I gave you a lot of info for 2. A lot of info. I guess really there's angles out because I just know the right angle and that's it. But I think side is still an option and side angle side similarity is still an option. It's just a matter of which one do you want to check. All right, which one do we want to check here? Side angle side or side side side? Make a decision for the class, please. 9. Audrey, make a decision for the class. You want to check it using side 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 or side angle side?
Side, side, side.
All right, let's do it, Audrey. Here we go. Take the smallest side of the smaller triangle, which is what?
9.
9 corresponds to the smallest side in the biggest triangle, which is
12.
12. Go ahead. What's it? Give me another pair.
15 and 20.
Okay, 15 to 20. And what's the final pair?
12 to 16.
12 to 16. All right, here we go, guys. I got to figure out, are all three in the same ratio? You can do the decimal option in your calculator. You can reduce. I believe they all come out to be 3/4, don't they? Okay, all of them are 3/4, so we're good to go. They all came out to be the same ratio, so these triangles are similar. Give me a good similarity statement here. Let's roll 8. Boom, Ryan, going back to you. Give me a good similarity statement here, Ryan.
Triangle MPX is similar to triangle AWL by side, side, side.
Okay, AWL by side, side, side. And just a reminder, side, side, side's a way to prove triangles congruent, not similar. So I do need to put the tilde next to it to let people know, hey, I was proving them similar. You guys all good? Good job, good job. All right, how about 3? Are these triangles similar? Well, if I go through all 3 methods, angle, angle, well, I'll get to that. But side, side, side is definitely out, right? Side, side, side is definitely out. I don't know the value of the third pair. Anything else you know true on this diagram before I move on? Anything else true that I don't have marked? 1-6. Kyla, anything else true I don't have marked?
Angle QMP is congruent to angle AMB.
Yep, vertical angles are congruent. So the only thing now it looks like it could possibly be a side angle side. Possibly be. I don't assume it. You cannot assume it's just side angle side. You need to see if the corresponding sides are in the same ratio. So I need to say to myself, 3 over the smaller side in the bigger triangle, 4. Is that in the same ratio as 4 to 8? Does 3 to 4 match up with 4 to 8? And you guys see, look, what do you guys notice? 3/4 is not the same ratio as 1/2. The sides are not in the same ratio, so done. That's it. In this case, they're not similar. So you can't go by the looks. You do need to test if all the sides are in the same ratio. Any questions on determining if they're similar or not? Because I got one more thing to do with you. Now it's time for you guys to make your own proportion and solve it on your own. Okay? If the triangles are similar, we talked about at the beginning of class today, corresponding sides are in the same proportion. It's time for you guys to make your own proportion now. So let me go to one of my top 10 word problems of the year right here with Natasha. Top 10, guys, top 10. Possibly top 7. I haven't re-ranked them in a couple years, but. So how about Natasha here? Placing a mirror on the ground 24 feet away from the base of an oak tree. An oak tree, because that's important, because if it was redwood, pine, maple, maybe it would affect the problem, but this is an oak tree. Oh, she's going to walk backwards until she can see the top of the tree from the middle of the. Can we just all agree that Natasha's got some free time on her hands, right? She's really taking COVID hard, all right, with all this isolation, social distancing. She's really taking this hard, all right? So she's at the town park placing mirrors and walking backwards. Find the height of the oak tree. All right, now here's where the point we're at. Is where you guys, given 2 triangles now, have to build your own proportion. And this is a lot of what the homework is tonight, is building your own proportion based on 2 triangles. Here's how I always approach it. I take one side from one triangle. So I'm going to start out with Natasha's height, 5.5, and ask myself, what side does that correspond with in the other triangle? So 5.5 would correspond with what value in the other triangle? 12, here we go. Lucas, again, what's 5.5 correspond with in the other triangle, Lucas? If I put those triangles right on top of each other, the 5.5 would correspond with what?
The X.
The height of the tree, X. So I put the two sides that correspond right over each other. Then I take the other side I know from the small triangle, which is 4, and see that that corresponds with 24 in the other triangle. Again, this is not the only way to write a correct proportion. If you guys wanted to start with 24 over 4 equals X over 5.5, that's fine. You know you set up a correct proportion if you end up cross multiplying the 4 and the X and the 5.5 and 24. That's how you know you set up a correct proportion. Multiple ways of doing it correctly, though.
I'm just saying that if you're able to simplify that fraction, like 4 over 24 into 1 over 6,
Yep.
if you know it's congruent for the other one, couldn't you do that mean when you multiply 5.5 times 6?
Correct. Yep. You're still going to get the same answer, though. Whether
But
you,
is that an allowed method of doing it?
yeah, that's fine. You should still get the same answer whether you reduced or not. Okay, so just doing this real quickly, 5.5 times 24. I end up with 132, everybody. Divide both sides by 4. 33. So the height of that oak tree, 33 feet. Make sure if the problem has units, so do you. Everyone all good?
In this case, you have to assume that they're similar.
There is a reason why they're similar is because, hey, I'm assuming these guys are standing straight up, so that makes a right angle. And then the angle the mirror makes to the top of the head and the top of the tree are the same, so you have angle there. Okay? But yes, all the triangles you will be involved with are similar because that's the only way I can set up the proportion. All right.
Like even with like problems like 2 and 3, you assume those proportional.
2 and 3. Oh, coming up. Oh, there's reasons why. Like number 2. Number 2 is going to be similar by side angle side. Because they both triangles have that angle, reflexive angle, and the sides surrounding them are in the same ratio. So that's why. Okay?
I guess
So,
I'm asking, should you bother trying to see if they're congruent?
or similar, I would not, no. Most of the time they'll come out and tell you anyway. Okay? All right. This one right here, real quickly. All right, I just didn't want you to hear that and sign off. All right, real quickly here. Everyone see how you have a smaller triangle and then there's a bigger triangle, correct? Everyone sees 17 as a side in the smaller triangle, corresponds with X in the bigger one. Now I take another side in the smaller triangle, let's say 15. Here's where you can't mess up. It does not correspond to 10. 10 is not a full side in the big triangle, is it? So you can't use it if it's not a full side. What does, go ahead, chime in somebody, what does the 15 correspond with in the big triangle? A full side of what?
25.
25, yes. All right, so you can only use full sides in these proportions tonight. All right, do not use partial sides, use full sides. All right, that's the only point I wanted to get across before I let you go. Okay, full sides only in the proportions when you write them. All right, guys, you guys have a good day. Be prepared for factoring or quadratic formula again tonight. Good work, good work. Have a good day. Behave, good night.